Welcome to Drink Scale Models. I'm Jason, your host, and I do models. Today we're going to be looking at this charge controller circuit. I talked about it in my traffic light project thing, and I was going to hook up my little battery here, my little 1000 milliamp hour battery I showed you in that video, to this to test it for charge. And before I hooked the battery up, I plugged it in just to see what it would do and to take some readings and stuff. And let's show you. It spazzes out. So that makes me wonder what is going on here. We'll turn that off for a second and we will get this up, because I want to show you that there is a voltage across where the battery hooks up of 3.9 volts, and that's about what it takes to charge a lithium cell. I am going, before I hook this battery up to it and this thing acts all weird and crazy, I am going to hook the electronic load up to it as soon as it's done loading down what it's loading down now, a battery pack. As soon as that's done, I'm going to hook the electronic load up to simulate a battery, and I'm going to put this thing through its paces and see, and basically, and then also hook it up to the power supply emulating a battery and see if this thing acts any differently. So yeah, I'm not sure what's going on there. What would happen if I hook up a battery, if I make my power supply, which is a singlet SPD 3303XE, in case you were wondering. Let's hook up this power supply and we will simulate 3.7 volts. I'll do 4 volts. We'll do 4 volts. 4 volts. And we'll start at 50 milliamps and see what this does. Simulating a battery being hooked up to it to put out power without the charger being plugged in, because I don't want to backfeed into my device here. So this really got tangled up. So, and then we'll take a look at the circuitry on it and see if we can't ascertain anything. Okay, that's all. Okay, all my red current clamps are missing. It's just strange. All my red current clips. Okay, sorry about that. Alright, so let's hook up this to positive and this to negative. So now we are simulating a battery hooked up to it, and let's set it down in view here, and we will turn this on, and it is on. Press the button. It is drawing no current. There we go. Now we're getting a connection. So, okay, so first of all, this is not working out with these clips. So I'm just going to swap clips here. That's why I like these interchangeable units. You can just, there, that hooks into the hole there. So we got our positive and negative hooked up. Let's turn it on. And we have, okay, we had something before. There we go. So it needs more than 50 milliamps. Yeah, so it shuts down at 50 milliamps. Let's give it 100. And let's... Okay, so, and it shuts off at that one too. There we go. We turned it on, so it says it's 84% charged because it's only, we're drawing 20 milliamps on it here. What does that do? Turns it off. Turns it on. So it doesn't say, it just gives me a battery output there of 84. That doesn't. That turns on the flashlight mode. Let's check the voltage out to the on the shell. Should be about 5 volts. No. No. Okay, so, okay, got that backwards. So 5 volts is here. So I got 5 volts on the output, but the unit turned off when I put no, it's still on, it's just not all lit up. So it's got that crazy blue-black light on it. So it seems to emulate a battery. Emulating a battery. What happens if I change the voltage to 4.2 volts? So if I do 4.2 volts, it doesn't change the see if it changes the battery. Yeah, see, it still says 84%. 30 milliamps. If I disconnect it and hook it back up again. So 99 at 4.2 volts, it says it's 99%. So you have to actually disconnect it and reconnect it. So it means it's got a lot of switching circuitry on it. Alright, let's turn off the power supply and let's take a look at what's actually on this thing here. So underneath, it doesn't appear to be anything but some traces. Let's take that off and put that on. And we'll take a look and see if we can see what that chip is there. Can we see what that chip is? Chip definitely has something written on it, I just can't see what it is. Okay, so we have, I'm assuming that's a microcontroller, and then we have, let's see what this, I'm not sure what that is. That could be a protection chip. And then we have another chip right here. Another chip right here. I'm not sure, another 6-pin chip. So we have another 8-pin chip. We have a couple either transistors or MOSFETs. A lot of capacitors, a lot of resistors, course, the LED is switch, and then we have the inductor. So definitely has it's definitely a boost up circuit. So it's an interesting thing. I'm gonna stop here, and then when my electronic load is done, I'm going to hook that up and see what kind of charge current it can put out when it's hooked to a charger. And then I might hook the power supply up to it again and see what it outputs for a charge with it hooked up to, like charging. Hook the battery up, hook the power supply up to it, and then plug a load from the electronic load in and simulate a battery pack charging and see what the display does. And I want to test this fully on everything before I hook it up to my little battery here and it blows it up. So that's it for this video, this segment of the video. I'll be back with more tests on this little unit. It doesn't really matter what the amperage is. So I'm going to plug it into my circuit here, and then we're going to turn it on, and it is going to come on, and it is going to say 57% charged. I don't know why it says 57% charged, but it's drawing 20 milliamps. So it's drawing 20 milliamps. And the battery reading on here being 100% is weird, but I want to see at what point that this shuts off. So what I want to do is slowly lower the voltage. So there 4.2 volts. Let's just go down to 3.9. Let's turn it off. Let's turn it back on. See what it says at 3.9. Still 57%. Let's go down to 3.5. Let's see what it says at 3.5. I find that you have to turn it on and off to do this here. Still 57. I want to see at what point it actually shuts off and it won't turn back on. So there's 3.2 volts. Still 3.1 volts. Okay, it's flashing 0%, so let's see if it turns back on here. It's flashing 0%, and I believe it's going to shut off. So at 3.1 volts, it shuts off. So let's try it at 3.2 volts. So 3.2 volts, it wants to shut off too, so 0%. So this is good, so that means it'll protect the cell. Let's put it back to 3.4. Will it even power the light? Yeah, it will power the light. But how long will it power the light for? No, it's still powering the light. So let's see here at 3.1 if it'll power the light. It powers the light at 3.1. Okay. So that light is still being powered. It's just going. So that light is directly across the battery. So I want to know, let's bring it back up to 4.2 volts. Let's turn off the light. So let's unhook it and hook it back up here. And let me get that. So it's at 99% at 4.2 volts. So what I want to do is just need to answer this. Okay, so at 99% and it's at 4.2 volts. So I want to see at what point it shuts off the 5 volts output. So I'm going to plug in, we're going to turn on this meter here, and we're going to unplug the DC power. We're going to measure voltage of the output of, and then I will get the meter software going here. There it is. Okay, so there is the volts DC, so I'm going to plug this into this output here. And I'm getting 3.2 volts. So if I turn the power supply on, I'm getting 5.1 volts. When does it shut that off? So let's bring it down to 3.7. Still putting out 5 volts. 3.6. Still putting it out at 3.2 volts. Still putting it out. So still wants to put out 5 volts at 3 volts. Okay, it's still not shutting that output off. Okay. So I'm going to come back to this in a second. Okay, so I am convinced that this has no battery protection on it. So I want to check out these chips on here to see if they're like DW01s and things like that. But first, a package has arrived from DigiKey. So let's take a look here. I don't know why they just didn't send everything in one lot. I'm not sure when this video is going to be released, but I just got a package yesterday from DigiKey. So, very good packing. Electrostatically sealed. This is all chips, so let's see what we got here. We have some 8K parallel 48 dip parallel RAM. These chips are going to be huge. I think I only got one, right? Yeah, I think I got one of these. Yeah, this chip is huge for 8K RAM. Well, you have to see how big this chip is. Look at that. It's huge for 8K RAM. But so these are cheap. So then we have here we go. This is nice. This is a 74 LS191. This is an IC up down counter 16. It's a binary counter, 4-bit, but you can count up or down. I ordered 5 of these because it's part of the LS series logic. And then I got here an EEPROM 64K DIP 28 EEPROM. I got 3 EEPROMs. I always use the EEPROM. Here is a LS193. It's another 4-bit up down 16-bit counter. We'll have to wait for the logic series before we we figure out what the difference is. And then we have another different type of SRAM 8K parallel, 48 dip. And then we have a EEPROM 28 dip, 64K parallel. So I got one of these. This one must have been expensive because I only got one. Yeah, that one must be expensive because I only got the one. So, but what I'm going to be mainly using is, where's that other EEPROM thing? They're both 64K. Okay, I definitely ordered the same chip on that one. I thought I ordered an 8K parallel EEPROM. I guess that was the smallest EEPROM I could get in parallel. So, I do a lot of hunting on DigiKey. So, and they take PayPal, which is great. So, let's get back to our little chip here and see if we can't find out what that chip is on there, and see if it is supposed to be a protection chip, and if me hooking it up and imitating a battery on the power supply is just not fooling it. That's all I can think is I'm not fooling it at all. No, I'm just getting the camera set up here. Okay, so that should be good. Almost. Is it gonna come up? Hold on, guys. There we go. Okay, so let's look at this chip right here. And can we see a name on it? Looks like an MP5043. That's not what I'm looking for. What is this one over here? Yeah, that's just an, I don't even know what number to use there. 5088SS. Not even sure on that. It's looking for a DW01 charge controller chip. So this may be just a boost converter, and it puts charge in the battery, but you need separate charge circuitry. I don't appear that there's a number on this chip here. No, there's nothing on that chip. I'm assuming it's some kind of discrete microcontroller. These things are like $2 or $3 on eBay or Amazon. They're like $2, and you get like 4 or 5 of them for dirt cheap. So, imitating a battery with the power supply, it will put out 5 volts no matter how low I go. So I don't know if maybe it needs a battery connected to it to cut off. I'm not sure. I am going to hook up this little 1000 milliamp hour battery to this. And what do we get? It says this is at 46%, and that's all it's doing, is just telling me 46%. So what happens if I plug in a, I'm gonna have to bring this, oh, that sticky came off. I'm gonna have to bring up my charge meter here so you guys can see it. So I have my Rodang charge meter here, And I need to just jot these numbers down because they're important. Hold on. Five, 6, 2, 3, 2, 8. We're testing a power bank. And this has my charge data from the charge. So far the power bank's not doing good. It's not a winner. It's 8,000 milliamp hours, and from dead to charge it only put in 5,452. And it only discharges, yeah, it's not good. So let's unplug that and let's come over here and plug it into our battery, and let's plug in and let's see what it's going to draw. Wow, it's charging that little battery at 1.3 amps. Wow, that's insane. Should have charged it with the battery. Let me tone this down a little bit, guys, so you can see what's going on. Okay, so battery's at 46%. I'm not real thrilled that it's charging at 1.43 amps here. For a little battery like that was at 46%. So it's slowing back down. It's coming down to 1.2. So the battery doesn't appear to be hot. It does have charge protection on it, so I want to know what the voltage is. I wonder if I can figure out what the voltage is going into the battery. I want to know what voltage they're charging the battery at. Let's see if we can find that out. So let's grab our probes here. And if we go across, let's put the meter up. If we go across the battery terminals here, I'm already in the right hand. Go across the battery terminals. About 4.1 volts. Now I wonder if that's the capacity, what the cell is sitting at, or if that's what's being put in there from the charger. See, the charger settled down to 1 amp, so that is actually better. Let's see here. We know that there is, man, I can't get this stuff. I wish this stuff would be on the screen. This is just a rat's nest of wires. There's a meter probe in here. This is just nuts. Okay, let's tone that down a little bit. Let's zoom in so we can take a look here. So the meter is still, you're gonna have to just take my word on the meter. It is 1.5 amps, or I mean 0.99 amps now at 5.11 volts. Let's see what the battery voltage is. It's still saying 46%. Battery voltage. So the battery's almost full. 4.2 volts. So I'm assuming the cutoff hopefully is 4.3, 4.25 is where I'm hoping it cuts off. If not, I'm going to cut it off there. It's not going to take that long to get there at an amp charge rate. So all I can think of is this chip right here does the decharge circuitry. Because I believe this right here is the switching supply, the one that, the boost circuit, I'm sorry, the boost circuit. I'm assuming this is going to be the boost chip, and this is the inductor for the boost chip. Here's your input and output capacitors. This microcontroller, though, this is what's, I guess this takes in the information from the battery, runs the light, controls the switch, controls the information that is shown on the little LCD here. So this, I'm assuming that this is the charge controller. It has dropped down to 0.8 amps, so 800 milliamps. The battery doesn't appear to be getting warm. So what I'm going to do is I want to come in here and I want to look at this trace. So I'm going to move my microscope in and see if I can get that on there here. So okay, so let's see what we got here. What is that? It's dropped to 700 milliamps. So that's a 5088 SS. Oh, bingo, we have a data sheet. It isn't all Chinese. Let's see what this data sheet did. It's a 201 lithium protection circuit. Let's see here. Okay. Not a robot. Crosswalks. It's a crosswalk. Okay, I'm just downloading the PDF so we all can see it. So let's get the microscope out of here. Let's go to monitor 1. Okay, so here is, oh great, I can read this. So this is definitely a 2-in-1 protection IC. You have a VM, NC is 4, and then you have your bunch of ground pins. So it's basically a MOSFET. Oh, it says it up here. Okay, so battery voltage 3.7, short. So it looks like it charges to 4.7 volts, and it cuts off between 3.6 and 2 volts. This is hard to understand. Is there a... No, this all appears. So, you have your power coming into 1, 2, 3. That has dropped to 600 milliamps. So, looks like pin 6 goes to the battery through the 1K resistor. So 3 lines come from the negative. That's where they're charging it from the negative. Okay. Let's go back to the overhead. Okay, so that is supposedly a charge protection circuit. Let's check our nifty little meter here. We're at 500 milliamps. Let's check our battery voltage. So we're at 4.18. So this may actually take a fair bit of time to charge this battery. This has actually changed. It's gone up 1%. So you can't turn it off if it's charging. This is always on if it's charging. So you can't turn the light on. Whether or not this shuts off before this protection on this circuit kicks in, I'm not sure. I looked at this on another video, the protection in there. I just have this so it's just easier, and it gets knocked around by my son or something. It's not going to blow up, because that's what cells do sometimes. So, my wife allows me to have lithium cells in the house. So, okay, so we found the battery protection. It says it's a 2-in-1 protection circuit. So, yeah, it says 2-in-1 lithium protection IC. There's no other kind of there's no other kind of just the Chinese version, just not a different version. Alright, so this is now at 500 milliamps. Let's just see it at 5.18 volts. It's putting about 4.1 volts across the battery. I'm assuming that's the charge voltage, is this 1.8, and I'm not getting the actual battery voltage. Let's unplug it and check the battery voltage. So we unplug it here, and let's check the voltage at the battery. So let's have 4 volts. So I guess it's charging at 4.18. Now let's put that in it's at 49%. Yeah, 4.18, so could shut off in time, we don't know. So I'm going to come back for one last final part of this. Actually, you know what? It's charging. I got another video on this cell, its capacity, so I'm going to finish it up in this video. This is going to do it for this video. This is pretty good. I might, in another small separate little video, I might put a large battery on here and subject it to the electronic load and see what kind of load. I don't want to put a huge load on this battery. It seems like when I mimic a battery with the power supply. It doesn't like it. It knows it's not a battery. So that is going to do it for this video, guys. Here's the links to social media, Patreon if you so want to help. There's also a GoFundMe in the description. Thank you so much, and have a